I apologize. I got cut off there, so I have to record a second video. We are up to number 3. Which function value f, g, h, or k of x is the greatest when the input is 0? What about when the input is 10? So we're going to start with 0. We're going to figure out which one of these has the greatest value when I input 0. So let's start with f. If I plug in 0, that's going to be 3 times 0 minus 7. So 3 times 0 is 0, and 0 minus 7 is negative 7. Okay. Let's go to G now. So this is going to be 3 parentheses 0 minus 7. All right, again, we're inputting 0. So 0 minus 7 is negative 7, and 3 times negative 7 is negative 21. All right, so that's GH. Again, plugging in 0, this will be 0 divided by 3 minus 7. So 0 divided by 3 is 0, and then 0 minus 7 is negative 7. And then K, 0 minus 7 divided by 3. Again, I'm inputting 0. So 0 minus 7 is negative 7. And negative 7 divided by 3, that's going to be a decimal. So let's use Desmos to get the decimal. So that's negative 2.3 repeating. So K is going to be negative 2.3 repeating. So when I plug in 0, I get answers of negative 7, negative 21, negative 7, and negative 2.3. Out of those 4 answers, which one is greatest? That's going to be function k. So when the input is 0, function k has the greatest value. Okay. Now we're going to do the same thing, except now they want us to check when the input is 10. So what happens when I plug in 10 for x? Which one is going to be the greatest? So we'll go back to f. Okay, now we're going to plug in 10. So this will be 3 times 10 minus 7. So 3 times 10 is 30. And 30 minus 7, okay, that's going to be 23. All right, let's plug in 10 into G. So this will be 3 times parentheses 10 minus 7. So 10 minus 7, remember PEMDAS, we always do parentheses first. 10 minus 7 is 3. So this is really 3 times 3, which is 9. Okay. If I look at H now, so this will be 10 divided by 3 minus 7. Okay, 10 divided by 3, that's going to be a decimal, so I'm going to use Desmos again. So 10 divided by 3 is 3.3. And then if I subtract 7, I end up with negative 3.6, or negative 3.6, negative 3.7. So when I plug in 10 into H, I get an answer again of negative 3.6 approximately. All right. And then let's do let's do function K. Again, plugging in 10. So this will be 10 minus 7 divided by 3. Okay, 10 minus 7 is 3, and 3 divided by 3 is 1. So when I plug in 10, I get answers or outputs of 23, 9, negative 3.6, and 1. Obviously, 23 is the greatest value. So when the input is 10, the function f has the largest value. When the input is 0, the answer is function k. And when the input is 10, then the answer is function f. Okay, so that is it for the first page. Okay, let's go to the second page. Okay, so that we're up to number 4 now. Okay. So number 4, a square that has a side length of 9 centimeters has an area of 81 square centimeters. The relationship between the side length and the area of the square is a function. Okay. So if you forgot, I'm just going to write this off to the side here. Okay. We should know from our past that in a square, all sides have the same length. They're all congruent to each other. Okay. And we should also know that in general, area, okay, is length times width. Okay. The thing is, in a square, the length and the width are actually the same. So in a square, the area, in a square, the area is actually just the side length of the square squared. Okay, because length and width are the same length. So area of a square is just the side squared. Okay. So that's just important to know. We're going to use that to help us. Okay. Complete the table with the area for each given side length. Okay. Complete the table, then write a rule for a function a that gives the area of the square in square centimeters when the side length is s centimeters. Use function notation. Okay. So let's do the table first. Okay. So remember, the formula is to simply take the length of the side of the square and square it. So for a side length of 1, okay, my area is going to be 1 squared, which is 1 times 1, which is 1. Okay. For a side length of 2, that's going to be 2 squared, which is 2 times 2, which is 4. So when the side length is 2, the area is 4. Okay. So for 4, that's going to be 4 squared, which is 4 times 4, which is 16. Okay. 6 squared. Okay. So 6 squared is 6 times 6. So that's going to be 36. And then the last table here is kind of hard to read. So let me take a look here. That looks like a G. Actually, that looks like an S to me. So my area is just going to be S squared, like I said. Okay. Um, so that's our table. So to write our function rule using function notation, remember with function notation, okay, we're going to call our function a, and the variable that we plug in for is s. So my formula is going to be a of s. Whoops. My formula is going to be a of s equals s squared. So the area is going to be equal to the side length squared. So a of s equals s squared. Okay. B, what does a of 2 represent in this situation, and what is its value? So a of 2, okay, a of 2, what that means is that means the area of the square of side length 2. area of the square of side length 2. And we saw in our table, when the side length is 2, the area is 4. So what is its value? Its value is 4. Okay. On the coordinate plane, so right here, sketch a graph of the function. So we're going to use the values we have here. So obviously, when the side length is 0, and I did it again, okay, when our side length is 0, okay, the area is going to be 0. So when the side length is 1, okay, when our side length is 1, our area is going to be 1, so that's going to be about right here. Okay, when the side length is 2, the area is 4, so that's going to be slightly higher. Okay. When the side length is 4, okay, the area is 16, so that's going to be about here, right? And when the side length is 6, okay, we said that the area is going to be 36, so that's going to be about here. So 36 would be about here. So when we look at the graph here, this graph is not going to be a straight line. It's actually going to be a curve. And let me use a different color here. So that graph is going to go up. It's going to kind of curve upward like that. Okay. So on the coordinate plane, sketch a graph of this function. We did that. So that is it for number 4. Okay, we have one more problem, number 5. So let's take a look at that one. Okay, a square with a side length of 3 feet has a perimeter of 12 feet. Okay, if we cut a square at 2.5 feet, what is the perimeter of the paper? So again, with a square, okay, we know that all the sides are congruent. They have the same length, and we should know that the perimeter of any shape is simply the sum of the lengths of all the sides. So we know that in a square, all the side lengths are the same. So I'm going to label that with an S. So the perimeter is going to be S plus S plus S plus S, which is simply 4S. So if I take the side length and multiply it by 4, I get the perimeter. And that pattern actually works here. 3 times 4. If I take the side length and multiply that by 4, or 4 times the side length, 4 times 3 is 12. So if I want to cut a square of 2.5 feet, the perimeter is going to be 4 times 2.5 feet. So 4 times 2.5 feet is 10. So that means it has a perimeter of 10. Okay. B, complete the table with the perimeter for each given side length. Then write a rule for a function P that gives the perimeter of the paper in feet when the side length is in feet. All right. So again, the pattern is to take 4 times the side length. So when the side length is 1, the perimeter is going to be 4 times 1, which is 4. Okay, when the side length is 2, the perimeter is going to be 4 times 2, which is 8. All right. When the side length is 3.5, it's going to be 4 times 3.5, okay, which is 14. Okay. 5, that's going to be 4 times 5, which is 20. And when the side length is S, it's just going to be 4 times S, or 4S. Okay? So complete the table, then write a rule for a function P. So unlike with area, when we did area, our function was A of S. Okay. For perimeter, our function, instead of using A for area, we're going to use P for perimeter. So it's going to be P of S equals 4 times S. Okay, that is the function rule for perimeter. Okay, C, what does P of 11 represent in this situation? So what this means is the perimeter of the square of side length 11. So P of 11 means the perimeter of the square of side length 11. What is its value? Its value is going to be 4 times 11, which is 44. Okay. On the graph, on the coordinate plane, sketch a graph of this function. Okay, so once again, when the side length is 0, our perimeter is going to be 0. When the side length is 1, okay, it's 4, which will be about here. When it's 2, it's going to be 8, which will be about here. When it's 3.5, it's going to be 14. So that'll be about here. When it's 5, it's going to be 20, which will be about here. So when I look at the points that I've put in, that looks like it's actually going to be a line. So it's going to be a straight line going through all of those points that we plotted. So that will be the graph of this function, 4 times the side length. So that is it for this lesson. Okay. I want to quickly take a look at the cool down, which is in your slideshow. So if we go to the cool down, okay, we're going to do the same thing with the perimeter of the square. So I would look at the last page of your handout to help you do this cool down. Okay, as always, if you have any questions, you can email me. And that is it.